Good morning, class. Let's go to page 3 of Unit 6, Lesson 2. Question 8. All towers and skyscrapers are designed to sway with the wind. When standing on the glass floor of the CN Tower, the equation of the horizontal sway, this way, is the following, where h is the horizontal sway in centimeters and x is the time in seconds. Use the table of values to help you graph this. So in terms of finding the values for the table of values, you're simply going to plug in 0 for this for this x value. And when you do that, you're basically going to do 30.023 times x, which is 0 in this case. Then you have sine 0, and we know sine 0 starts at 0. So for all this, you can use your calculator. Just make sure that you are in fact getting these values, because you don't want to be in a situation where you're not putting like the input correctly and then you're getting all of them wrong because of that. So you want to make sure you and I are using the calculating the same way. Notice that there's a degree sign, which suggests that you should be in degree mode, which is the factory kind of setting. But sometimes your calculator is accidentally in radian mode, so make sure you're in degree mode. So going from there, we plug in 3, I'm getting 40, and then 0, negative 40, and take pauses throughout the video and make sure you're getting these values. And so these are the values that I'm getting. So in terms of how I draw my graph, so I'm going to start off by noticing that, okay, so my max is occurring here at 40. My minimum is occurring at negative 40, which is the minimum. And the axis looks like it's at the 0. So with this at the back of my mind, I'm going to first draw the y-axis and then draw the x-axis. So we have a value of 40 and negative 40 for the y values. So we're going to write this as height in centimeters. That's 0. So in terms of my x values, what does x mean? Well, you basically have a horizontal sway. And if I was to draw my CN Tower, like if this is my CN Tower, I'm looking at it at like that angle, it's going to sway a little, just slightly. It's in centimeters, right? So it's so subtle, 40 centimeters relative to how big this CN Tower is. And so it's going to sway to its max and to its min. And then from there, let's write down the x-axis value. So we have 3, 6, 9, 12, and 15 based on the table of values I was given. So following the table of values, I have 0, 0, 340, 6, 0, 9, negative 40, 12, 0, and then back up at 15, 40. So that's what the horizontal like sway looks like. That's the max, that's the min. Okay, so in terms of like making little connections, I'm noticing that, that 40, that value ended up giving me the max. And there might be some relation here, and maybe you're able to make some connections as to how this table of values, this equation, and this graph might come all together as a teaser for later lessons. What is the period? What does it represent? And so remember, you're always kind of trying to look at it as a sine graph, which looks like this, like more like that. And then cosine is like this. So you can always look at these sinusoidal graphs in different angles. For example, one way I can look at it is, and it's like the nice way because it doesn't take any shift, that is one period, right? And this is a sine graph. And so it makes most sense that I'm comparing with a sine graph. But at the same time, I can see also a period if I look at it as a cosine graph. And either way, notice that the period is going to be the same. To not confuse you or confuse you a little less, I'm going to look at it like this. So I'm noticing that because these are 12 and this is 15, the period for this graph is going to be 12. So I'm just going to quickly say that the period is equal to 12 minus 0. I looked at the right point x and the x point x. And therefore, I can conclude that this is 12 seconds for the period. And what does it represent? Well, basically, you have your CN tower, and it's hitting its max horizontal sway of 40, and then negative 40, and back and forth. And so it is how long it takes for it to go hit its max, hit its min, and then come back to its original spot. So we're going to say that it represents the time of one full sway. Question C, let's state the maximum and minimum values of the sway and the times at which they occur. So, for example, I'm going to write that we realize that the max is 40. The minimum is negative 40. And when is this occurring? So I'm looking at my max. So max is occurring at 3. I'm also noticing it occurs at 15. So at 3 and then 15. Well, how do I go from 3 to 15? Well, if you notice, see how I can add 12 to that. 3 plus 12 is equal to 15. So that means if I add another 12 to it, well, 15 plus 12 is 27. And then 27 plus 12 is 39. It's going to keep going. So I'm going to write this down and say at x equals 3, you're going to get 15, 27, 29. So you're basically going to add the period to get this. And sometimes you can come up with an equation to do this. So for example, you're kind of sometimes doing it so that, okay, if I have my x and my position number is n, that is, this is like position number 1, this is position number 2, this is my position number 3, etc. Like it's the first number I got. Well, I know that I want 3 at the end of this if I plug in a 1. And my thought process of getting this like equation is, well, the difference between each of the numbers is changing by 12. So I'm going to say, okay, 12 times n. Well, if I multiply that number by 1, I get 12 and not 3. So to change that, I'm going to subtract that by 9. So if I plug in 0, I'm going to get 12 times 0, and then it's a negative 9. So its initial position, so x to the position 0 is going to equal to negative 9. X to the position 1 is going to get you 12 times 1, which is 12, minus 3, which is equal to 3. Check that it works for this position as well. 12 times 2 is 24, and then 24 minus 9 is 15. So this in black isn't really my focus. It just kind of teases you into a future unit that we would have done called sequences in series. So when is a minimum occurring? Minimum is occurring at 9. And if we were to continue this graph, it's going to occur every cycle, right? So I'm simply going to add 12 to this as well to get my respective minimums. And so I'm going to get at x is equal to 9. And then you would add the period. And so 9 plus 12 is 21. And then you get 21 plus 12, which is... And I'm just going to add in this part, this should be where all numbers are integer numbers, like it has to be positive or negative whole numbers. And this is a check and where you say, okay, let's say my position number is 1. That's like the very first number. If I plug in 1, because this is 1, and then I subtract 9, I do in fact get 3, which is the very first number. Or future unit. So for question D, it says state the mean value of the sway and the time at which it occurs. So what does the mean value mean? Well, mean value means so So for question D, it says state the mean values of sway and the time at which it occurs. So what is the mean value? Mean value is the average, right? Like the average value, average grade. You're familiar with that concept, right? And so for this sway, it's really referring to the axis because it's going to oscillate around this axis of 0. And so mean means average, and in this context, it means the axis, and therefore it is occurring at 0 centimeters. And when is it occurring? Well, I see that it hits it at 0, at x equals 0, x equals 6, x equals 12. Notice that I'm not saying y equals 0, but these are the times when it's occurring. And if you notice, it is occurring 3 times. And if you're looking at when that occurs, relative to the first point, it is occurring halfway through the period. So instead of adding a period to these values, you could get any of these values by adding half the period to get this. And therefore, you would say it is occurring at 0, 6, 12, 8, 24. And I am adding plus half a period every time. If I was to make one of these position equations, I would do x to the it's not exponent, sorry, it's subscript n, which describes the position it is at. This is position 1, 2, 3, 4, 5. So what I need to basically get is that when I plug in 0, it needs to equal to 0. When I plug in 2, I need to make it equal to 6. What I usually look at is take a look at the difference that is occurring between these values, and you can kind of think of it as a rate of change. The rate is occurring at a difference of 6, and I'm going to multiply that. So that would be 6n. But if you double check, and if you plug in 1 for position 1, you would get 6 instead of 0. And to avoid that, I'm going to subtract 6. That way, if I plug in 0, I will get 6 minus 6, which is equal to 0. If I plug in, not 6, but position 2, I'll get 6 times 2, which is 12. 12 minus 6 is 6, which is what I want. And so this also is respective to integer numbers, and I've indicated that. And if I was to do a quick check, basically what I was talking about verbally, at x with position 1, you would do 6 times 1, because n is equal to 1, minus 6, and you get exactly x1 is equal to 3. And I'm going to get, well, this is going to equal to 0, and the first number I get is 0. For E, if a guest arrives on the glass floor at time equals 0, how many seconds will have elapsed before the guest has swayed 20 centimeters from the horizontal? So what that kind of means is that when you're at the CN Tower, I mean, you're going to feel like you're still, but the CN Tower is going to shift slightly left and right. And so it's asking when is this going to occur? When is H going to equal to 20? Therefore, your position is also 20 centimeters off compared to where you started from. And we do have to pick a position and assume where they mean, because do they mean plus 20? Do they mean minus 20? And because you're going to get different answers. So we're going to just specify that you're making an assumption that this is assumed to the right. So when you do this using a graph, it's not a very accurate guess. So when I draw this out, I can guess that maybe the values is about 1.5-ish, but it's a guess. And then it's maybe a 5, maybe like 13, 14. It's hard to guess, and I'll write down what my guesses are, but it's not as accurate. And I'm just crossing it off and checking it off just to tell you that I verified some of them. So we're going to look back at the graph so I don't have to keep going back and forth. And this is our graph. And let's look at our equation. So if we're using the equation, how can we arrive at the correct answer? So scroll up. That is our equation. So let's write it down. h at x is equal to 40 sine 30.023x with a degree sign. So first part, what are you going to do? Let's think about it for a second. I discussed with you that basically h is equal to positive 20, and you need to find the times that this is true. So see how that kind of reminds you of like typical equation problems where you know like one of the values like this one, and you need to solve for x. You're rearranging. So that's what we're exactly doing. So what we're going to do is sub h is equal to 20 to try to solve for an angle. So when we do that, we're going to get 20 equals 40 sine 30.023x angle. So remember, when I see complicated cases, try not to think about it too hard and say, okay, I'm going to deal with it later. Once I get a nice number, I can simply divide by 30.023 and get my x anyways. Why make it complicated? So I'm going to say let theta is equal to 30.023 x, and then we're going to go from there. So now you have a simpler equation where it's 20 equals 40 sine theta. And when we do that, we want to get sine theta by itself. So we want to solve, well, eventually for theta, or solve for sine theta first. So I am going to divide both sides by 40, and I get sine theta equals a half. So there's two ways of approaching this, okay? And I'm just kind of thinking it out loud if I'm a student. One thing you're going to do is just use a calculator, right? You're going to get your answer and it's going to work out nicely. So sometimes you're going to use a calculator and you'll get a nice answer. You'll get a really nice answer. And if I do sine inverse for this question, I will get a theta of 30 degrees. But there are some cases where you do not get a nice answer. And we have to prepare for those cases and know the full picture of what's going on. So I'm going to verbally tell you that you could have gotten this next part using a calculator, but just be prepared for all situations, okay? So for the second part, we have, we're going to use a special triangle. So what that means is when you get a value, whatever value you get, you might try to see if you can use a special triangle because remember how there are variations of square root 3, 1, 2, and square root 2 that comes up. And if you see any combination of these values, you might have to double check and make sure that you are giving us a very specific angle and keeping it exact, okay? Okay, so for now, when we have this special triangle, with the 1 and 2, I try to remember to myself and remind myself, when have I seen a special triangle where it has the numbers 1 and 2 there? So there's a couple of variety, actually. There's one version where it's 60 degrees, 30 degrees, 1 square root 3, and 2. And you might almost think that the 45-degree angle might work. And that was kind of my first thought at first when I was like, oh yeah, 1 and 1, and then 2. Oh no, but then there was a square root 2, and so that's why I'm going to disregard it. So that's why I'm looking at this triangle and going from there. So what does this mean? Right now, I am dealing with sine theta. Sine theta suggests sine theta is equal to opposite over hypotenuse. That means my angle will have a side length, so my theta is based on my opposite side and hypotenuse side, right? So I am going to say, well, hypotenuse is always consistent. So I'm going to say this is hypotenuse. So obviously, this has to be opposite because of the ratio given, right? And so that means what is the angle of interest? The angle of interest must be this one right here because that's the only way this is going to be opposite. So do you see that? So this is a special triangle way. And we could state that sine 30 degrees is equal to 1 over 2. Okay, so let's move on. We know now that the related acute angle is 30 degrees. Step 3. So we have to go to step 3. So step 3 is using the cast system. So I'm going to say draw an angle on cast to find terminal arms. CAST. Right now we're doing with sine ratio. And we did notice that sine theta was equal to a positive a half, right? And so we are going to say that according to CAST, my angle must be here. It wasn't sine theta equals a negative a half, instead a positive. And so I know my terminal arms are going to be here. So based on this, I can use my related acute angle of 30 degrees and draw it in my respective angles. So this is 30, this is 30. That means according to this, my first angle, my theta 1 must be 30 degrees. My theta 2 must be equal to 180 minus 30, which is equal to 150 degrees. That was actually my step 4, but I'll write it more explicitly in step 4. Step 4 is state as using cast. So I'm just kind of rewriting what I wrote there more clearly. But therefore, theta 1 is equal to 30. Theta 2 is equal to 150 degrees. Are you done? It looks nicely done, right? But you have to remember what variables we started up from. So we actually started from a variable of h and x. And common mistake is people leaving it like that. I mean, it looks pretty good, but you have to make sure that you go back to where you started from. We just did this so that our life was a little easier. So we have to go to the next step, which is kind of simple as long as you remember to do it. So you have to say find x, given that theta is equal to 30.023x. And like I said before, it's all you do is, so theta 1 is equal to, you have 30 degrees is equal to 30.023x. You're going to divide both sides by 30.023. And you're noticing that that's basically 30 degrees if you round, and you commonly round the degrees into the whole number anyways. And so you can say that the first angle is 1 degree. Are you done? You're not done yet because you have to deal with the second one. The second one said theta is equal to 150 degrees. You're doing this exact kind of same steps. You're going to divide both sides by 30.023. And so x is equal to, x to the subscript 2 is equal to 5 degrees. Notice these are very small numbers. So let's take a look at the drawing. I do want to go back to this drawing and draw my 20. Looking at the graph is also helpful, although the equation will give a really good job of giving you very exact or close to exact numbers like so. The graph is often really nice because it tells you how many I'm looking for. I'm looking for 1, 2, 3 coordinates with relative to at least the graph that I have right now. And so you shouldn't actually finish at this because this shows me that you're kind of doing the minimum work with related to this work. You should try to do one more step of where you're adding the period of 2. Adding a period of 12. And so it's going to look like, well, to find x3, you're doing x1 plus 12, and I'll get 13. Well, x4, I could do the previous one, the x2 plus 12, and I'll get 17 degrees. And then maybe for my x5, I can go back to my x3, which was like the other part. So I do x3 plus 12, and I get 25 degrees. And you can keep on going if needed. And we should have a therefore statement, and I'll say therefore maybe like 1, ooh, big no-no. I like assume this is degree because we're kind of like in degree mode with everything. You know what? This is kind of good that I made a mistake here. I should put degrees all over there, which makes me lose the degree sign over there. Let's erase those mistakes. What's happening is that if you have degree divided by degree, those are going to cancel out. That means you no longer have a answer with units, or at least in degrees. And you could say that the answer is, so therefore at 1, 5, 13, 17, 25 seconds, the guest has swayed plus 20 centimeters from the original. So I added one more circle over there, and I added the word position. So at 1, 5, 13, 17, 25 seconds, the guest has swayed plus 20 centimeter from their original position of the starting point. So you started off there, and they were so they started off at a horizontal position of 0, and then they swayed 40 plus 40 centimeters, and perhaps that's like to the right, at 1, 5, 13, 17, 25 seconds. It would be good to at least write down these 3. So basically what we have is we have this part in terms of degrees, whereas the x, according to our units, for question F, it says find h at 2.034. What does it represent? So this represents that x is equal to 2.034, and you're subbing x equals 2.034 as this is the input. Meanwhile, this is the name of the function. And so you have h bracket 2.034 is equal to, and we have 40 sine 30.023 times 2.034, close bracket with a degree sign. So you're solving for h. So when I multiply what's inside of here, I'm getting 40 sine 61.066782 with a degree sign. So I'm going to do sine answer, and I get 0.8752. I'm not going to write that down, and I'm going to straight multiply that by 40, and I'm getting 35.007 dot dot. So I'm going to round that to 35.0. And in terms of my units, it should be in terms of centimeters. So what does that represent? It means that time is 2.034 seconds. So you're trying to figure out what the position of the CN tower is at 2.034 seconds, which is approximately here. And looking at the graph visually, we would have anticipated a value a little less than 40, and we do get, in fact, about 35 centimeters. So you would write a therefore statement that says, therefore, the horizontal position of the CN tower at 2.034 seconds is approximately plus 35.0 centimeters.